solar mini-grids have turned from small pilots to an electrification wave. We were there when mini-grid regulation was established. When financial transactions were closed, we saw new technology thrive and companies fail. This is where we tell the stories. This is where we discuss the future. The mini-grid business, powered by Inensys.
Welcome to another episode of The Mini-Grid Business. My name is Janis Holzigo and I am the COO of Inensys and your host for today's episode. Today, we have an electrifying debate for you, recorded live from the Energy Access Investment Forum 2025 in Kampala. Once more, we're diving into the world of mini-grids and more specifically the question, when implementing a mini-grid, should we go for the flexibility of containerized power systems or stick to the traditional route of building powerhouses for these projects? Or shall we try an entirely new approach by utilizing prefabs? With me today, we have two excellent guests. On one side, we have Julie Roberts from SustainSolar, who builds and implements containerized power systems. On the other side, we have Abhishek Bharadwaj from Equatorial Power, who is now pivoting to prefab solutions. Welcome to both of you.
Thank you.
Thank you.
All right, let's dive straight in. Julie, let's start with you. Containerized power systems. We hear a lot about them. Could you please explain what these containers look like and how procuring and installing them works exactly?
Yeah, sure. Thank you. And thanks for inviting me to this conversation. When we're talking about containerized solar power systems, we're very simply talking about retrofitting a used 20-foot or 40-foot shipping container. Inside, we pre-integrate all the key components, the charge controller, the batteries, inverters, distribution panels, pre-wire and test everything at our facility, and then ship it out as basically a turnkey, ready-to-go, plug-and-play solution. From a procurement and installation perspective, it really simplifies things for the mini-grid developer. Rather than managing multiple suppliers and contractors, they receive a fully integrated system.
Fantastic. Thank you so much. So, Abhishek, in our preparation for this podcast, you had mentioned that you originally used containers, but are now pivoting to prefab solutions. Before we speak about why you pivoted, perhaps you could explain a little bit about what exactly you mean by a prefab solution.
Hello, everyone. Pleasure to be here. Yeah, let's start with what a prefab is. I don't think everyone knows that. So a prefab or a prefabricated structure is a building whose components are manufactured offshore in factories, and then they are transported as individual panels, which are then assembled together on the site. There are many types of prefab structures, but the one that we use or we selected for mini grids is something called SIPs. It is essentially structural installation panels. It is nothing too complicated. It is two galvanized steel metal sheets as like the outer layers of the wall, and sandwiched in between is a polymer foam. The density of the polymer foam itself allows to increase the strength of a particular wall that is constructed with this. And it is lightweight because it's just polymer foam. And an additionality is that it helps in maintaining a temperature gradient between inside the room and outside because of this insulation. So overall, it enhances, the design flexibility is sustainable, and more so, it is safe to transport and construct on site.
All right. Great. Thank you so much for that introduction. And I believe this is where I also come in, because Inensys does have some experience, of course, in building mini-grids and basically constructing powerhouses. So we have used two different approaches in the past. On the one hand, we have supported Umeme in Tanzania. And when we did that, we utilized powerhouses that we constructed locally. On the other hand, we also do have experience actually using the container from SustainSolar. And again, that makes me very happy to have Julie here as well. So when we constructed powerhouses at the mini-grid sites in Umeme, again, we did this in a very localized manner. Basically, these sites that we have built, they are on islands in Lake Victoria. And what we did was that we sourced most of the material for the powerhouses locally. So the stones are sourced locally. Then the only things that we had to transport into the islands were actually the metal sheets for the roof, as well as the cement that we got onto the islands using boats. And then once the materials were all on site, we then used a local foreman as well as some construction workers to actually build the powerhouse. And in our case, I believe that we were lucky enough to have a very good foreman that was actually following our plans and that also immediately included the space for cabling in the construction. But yeah, that may not be the case for all mini-grid developers, of course. But again, for us, we were very lucky. But back to our guests. Let's get down to the nitty-gritty of the technical setup. And one of the big questions here is how everything actually fits together. So Julie, when it comes to the equipment that needs to go inside a mini-grid, so the batteries, inverters, transformers, everything else, how do you manage to actually fit all of this into a container? And can it all really be integrated in this very compact space of the container? And then also, how do you deal with different sizes of systems that are requested by your customers?
Thanks. Good question. I think every mini grid is almost a different size. So it's hard to generalize completely, but so far we found that most equipment can fit comfortably in a 20-foot container. It's sort of like Jenga, I guess, or a Tetris. It's an intelligent design. There's trade-offs. We have a talented and experienced team of engineers that put together the different configurations. We're also technology agnostic, so we're not stuck with one particular solution or form factor. So we can really optimize both the volume and the area inside, as well as meeting the technical demands required by the developer for the mini-grid site. And we ensure there's adequate airflow and ventilation for cooling. There's safety spacing for serviceability. You can reach all the components. Inside the container, we weld Unistrut directly onto the container walls to hang the inverters on, so it's good and solid. And then we also do insulation for temperature control. We have cable trays to keep things tidy and secure. So yeah, it's really not a problem to fit it all in. If it's a very large system, we use a larger container. If it's a very, very large system, we can put power electronics in one and the batteries in another and tie them together. And then also, because we do all of the container modifications ourselves, we can be very creative. We can put a partition wall. If it's a smaller system, we can put the electronics on one side in a secure room, and then the other half of the container can be opened up maybe for like an electric vehicle kiosk, battery charging kiosk, or maybe there's a remote classroom and you have the equipment on one side and the rest of the container is left open. So everything is just very, very bespoke, very modular, and very customizable.
Great. Yeah, that really sounds like you're offering a very flexible solution to your customers. And then Abhishek, so the prefab systems that you're developing, they may have a little bit more space than a containerized solution. We've already now heard from Julie that she may have to use 2 containers instead of just one. But in your case, then how do you ensure that all the components fit together efficiently? And are there any drawbacks or challenges that you're dealing with when it comes to designing these prefab systems, and especially when looking at the size, cooling, other operational factors?
Sure. Thanks. I can take on from what Julie said. We can do all of that, what she does, in a better and easier way. The primary advantage of a prefab solution lies in the flexibility and ease of customization. Thanks to the modular design, because we are dealing with individual panels, we can expand or reduce space as simple as like removing or adding more panels. If containerized is a Tetris solution, we are a Lego set for kids, and kids will love playing with Lego, so ours is exactly like a Lego set. But to be serious, the entire design is reminiscent of the IKEA-based furniture, where it is individual components that anyone who's unskilled can also put together with a manual. This comes as simple as that. It has interlocking features which are very easy to assemble between the panels. But that being said, interlocking features and the U channels that we require to mount the system on the ground, while they are very easy to install, it all depends on the manufacturing quality of the prefab manufacturer. Now, over the last few years, because the prefab solutions have been used for wider sectors beyond our applications, there is critical mass that has allowed for scalability and better manufacturing. And the ones that we bought from, surprisingly and good for us, it was perfect. It was the first plant was installed in a matter of hours. Now, well, there are a lot of benefits. We will still go through those benefits, but there are limitations as well. One limitation compared to the containerized solution is, as Julie mentioned, the ease of mounting components such as inverters and heavy components such as batteries. They can do it against the wall of the container, and the wall of the container is solid. In the prefab, however, while the wall itself is quite strong, it depends on the interlocking joints to keep it together, and that cannot probably take the weight of these components. So the only addition to, say, a container solution we would have is an independent rack that we pre-designed and got it welded locally, because it is just welding a bunch of shelves together and mounting it on the ground, say 1 feet away from the wall, and then we could install everything in a compact way. So with that as a limitation, it didn't cost as much and it did not take much time. So it is something that, we could accommodate within our solution.
Yes. So, I mean, you shifted from the containerized solution, as far as I understood, to prefab, right? So is that point that you mentioned that you can do everything better, is that why you shifted, or what was the exact reason for shifting?
Okay, so if you go back to the history, the first project that we did was like the one that Jumeme did on your island. So we also installed our first site on Ijwi Island on Lake Kivu. So it was the similar kind of an island setting. In our first project, we went with the solution that you spoke of having a concrete room using local resources and the local expertise, because the island is large enough to have all the material required for a power room, while the power room is quite strong and it still stands. The issue was the amount of time it takes to construct an entire room. It took over a month in different stages, from the foundation to building the room to waiting for it to dry, and then having a second finishing, waiting for it to dry, and then a paint and waiting for it to dry. While our focus in the first project was on the technical side of like the demand assessment, on having a perfect system in place, we were not really bothered about how the power room is. But once that was done, the very next project, we worked with SustainSolar Power, whom a co-panelist represents, and I think the container solution worked really well to avoid the delay aspect of it. So containerized solution, it came ready to go. As soon as you have the system on the ground, within the next 10 days, you install the panels, and it is an easy to fit solution of the components into the container, and you're good to go. But it was not without issues, because we were in an island kind of an environment. The terrain is almost unsurmountable. The topography is quite hilly, so the gradients and lack of roads inhibited us in transporting the container through those roads to the project site. In the process, there was some material damage, but it was also a higher safety concern on the truck which is carrying this falling off. Another aspect is you need specialized crane trucks to offload and onload, and this is something that you don't get in remote areas. So we will have to obviously wait for the time for it to be available, and then take that to the island through this terrain to the site. So that provided quite a challenge. We did do 2 or 3 sites with a container solution, and then we quickly had to pivot to look for other solutions, which is where we came to the prefab solution. Now the prefab solution has a lot more advantages, the partitioning is something that we can do very easily in prefab as well. We can put a partition at anywhere between each panels that has the flexibility of increasing efficiencies, and all this we can do at the site itself. We don't have to customize it before we're taking it to the site. The bigger aspects are like scalability. So whenever you have an increase in the project size because of demand increase and we want to scale it up, it is just a matter of adding few more panels, and very simply, and within a couple of days, the power room is now twice the size without really needing to, again, building another room, which both takes time. Another thing is relocation flexibility. And now I will come to like actual instances of when this has happened and how we overcame it. There was one site which was like, through a program that we had done. But as soon as the program ended, we decided that the area where that particular standalone site was not the best place. And we needed to shift it to another community. And for that, we just had to take out the panels and then reinstall it elsewhere. And this happened within a week, that we totally moved a site. And this is like unheard of in the mini grid or a standalone setting, on how quickly we could disassemble it and like put it back together. Another advantage is a dynamic space reallocation. This was a very interesting dynamic. So we had 4 sites with prefab solutions, where one of the sites was considerably larger in size. And we later realized while we were operating that, this required a lot of spares and it needed a storage space that was not available. Then it perfectly fit the amount of components we had. So we went to another site where there was enough space. We quickly removed about 6 panels, closed that room, took these panels to the larger site, and then within 3 days, we have a larger space. Then we have a storage room with a partition. So this amount of flexibility is something that we recognized in happenstance. Like, we never really planned for it, but now we know that, we have that flexibility. So these real world examples really gathered more confidence into a prefab solution for the time being until we get a better solution. So we always like to innovate and try new things. But for now, we are sticking with the prefab solution for this very flexibility.
All right. Thank you, Abhishek, for the detailed explanation. Julie, obviously, Abhishek has spoken a lot about flexibility and about being able to do everything that you guys do, but better. So how would you like to respond to that?
Hey, I'm not here to compete with Abhishek. I think anybody listening to this podcast and any developer who's doing work at the last mile is dealing with all kinds of issues. And I can't even imagine trying to get one of these containers onto an island on Lake Victoria or Lake Kivu, whatever. And so if that is the best solution for that particular place, that's fine. Yeah, the containers are big, they're cumbersome. You do have to have some sort of mechanism to get this thing off the truck and down onto the ground. And safety is always a concern. And people tend to flex the limit. If the crane is limited to 10 tons, but your container weighs 13, some people will shrug it off and do it anyways. And what kind of risk? You don't want to take those risks. So I think it really speaks well to Equatorial's flexibility and be able to think dynamically on site. I am sure all the mini grid developers are looking for all kinds of solutions. And so I think it's more of a portfolio approach. Are there good roads? Is there access to vehicles? And what are your limitations? How many sites do you need to do? How remote are they? Some roads are truly rivers in the wet season, and some are actually on a lake. I think it's about finding the right solution for the developer. There's so many things that a developer has to juggle. The advantage of the containerized solution is that it is all pre-integrated and tested. We have a load bank. The wires are all cut and crimped and installed. The switches work. Everything. We know that it works where there's power. There's a welder and everything is set to go before it goes on site. For some of these places, it is by definition remote. There is by definition no electricity there, which is why the mini grid is going there. So if you do have a need to weld something, you're going to have to either bring in some other thing to weld it or take your equipment back out. So I think the additional value of a pre-integrated container is all of the engineering that happens inside the envelope. It's not just about what box it's in.
Yeah, great. And I guess it's not only the engineering that is sort of a bit more predictable as well. It's probably also the cost aspect.
Thank you. Good prompt. Yes. Even on a personal level, when you're trying to get a contractor to do something, there's always variations in understanding and estimations, and the cost can quickly double, triple, etc. And so when we're doing a containerized solution for a developer, we design the system together, we choose the components, we have a contract, we have a price, and we have delivery terms, and we have to deliver within that. So from a developer point of view, that part of the risk and the cost is controlled. And in this environment where things you can't even imagine go wrong, I think it's a little bit of a load off their shoulders, or a little lighter to think about, okay, at least my generation system is going to come and it's going to work. Now I can focus on, maybe it's the distribution network, maybe it's the end customer connections, because that's what really the developers need to work on and focus on and have their resources dedicated to, is servicing the customers. So if we can take this engineering one-time heavy lift off of their plate for that particular site, then they can do their job better, servicing the customers.
So Abhishek, I mean, you actually have that engineering burden, right, with you with the prefab solutions. In terms of resources, in terms of costs, does that impact the tariffs that you end up charging customers because it's more expensive up front than, for example, the container solution? Or how do you compare the costs between the different solutions that you have implemented?
Sure. Before we get into the cost, I definitely want to obviously address a fact, Julie, that it is true, like in our experience of using containerized and the prefab, the containerized came in a beautiful predefined slots where you know where you're going to mount the inverter. You're not like, thinking of your feet on the site. You have all the components well designed and well transported. So yes, that is an advantage. On the prefab, you need to think a little more of your feet. And yes, in places where it's plains, considering that we ignore the rest of the benefits of customizability on site and scalability, a container solution, if it can be transported, it is easy to set up. So it does work as well. So this is not like, not that prefab is the ultimate solution. Now, on the cost, I would like to go deeper into what the expenses are compared to containerized solutions. You really raised a good point, John, is that every dollar saved for a mini grid developer has an impact on the business model, as well as what tariffs we would charge and what the levelized cost of electricity is. So we do always we look at every component. We try to increase our sustainability in the way we source, the way following the procurement guidelines, and yet be sure that we are getting the best out of our system in terms of cost. Now, going into the components, just listing down the components itself, we have concrete foundation. This is similar for containerized solution. This is similar for prefab, so the costs really cancel out. Oh, before I get to that, we are never going to do concrete rooms. I mean, that was far more expensive than a container or a prefab. So we are taking that out of the picture. So this is only between a containerized and a prefab.
Well, why was it so much more expensive?
It is because of the remote settings and what it would essentially cost for a brick and cement in the city is not the same as probably a remote island. Yeah, so it was considerably more expensive, and we needed expertise masons who were available there, but we also want a quality. We don't want a mud based or a poorly constructed building, because we have a powerhouse which has to last for 20 years. So we've gone through the concrete foundation. We'll come to the material costs. In terms of material itself, if you look at a container, which is a 20-foot or a 40-foot, an empty container, you compare it to the prefab sheets, the material itself is less expensive on a prefab structure. Because we've done both the projects, we have a good comparison in terms of the sizing of the project as well to do this. So we found that, it was more efficient. Transportation, the prefab wins it because we don't need trucks for installing the prefab panels. Each panel weighs about 20 kilos that I think I can carry, and the people in the village or a community can carry 5 at a time. So we didn't allow them to do that, but that's how simple it is to carry and install. Then there is installation. The installation again is not very different. To put a prefab room together, you need 2 unskilled labor working for 1 day with somebody to monitor it, where we will have a technical project manager monitoring it. So the differences is not much, so that cancels out. Of course, the mounting assembly, that was something that we do on the site. So that is something that would obviously have an additional cost to us. But since it is local welding and using local metal, it was not expensive, and we did that within 2 days. Now, overall, if you put all this together, the cost efficiency per square meter was better in prefab, considering the fact that containerized, as Julie mentioned, comes in 20-foot and 40-foot. Now, any less than 20-foot the costs are better for prefab. Anything between 20 and 30, the costs are better for prefab. But anything above 40, costs are easily better on prefab because of the scalability and the replicable nature of it. The last thing I think I will touch upon is the operations cost itself. So it is easy to maintain. I think both containers and prefab are like equal in terms of maintaining the system itself. Both are robust, both have a long life. So there's not much of a difference. But if there is a relocation cost or an expansion cost, then prefab clearly wins because of the modular nature. And the fact of something that I did touch upon in the beginning is the cooling aspect of it, because of the insulation and the temperature difference between a room, which is lower in temperature than the ambient temperature outside. This allows for better functioning of our components. We all know that, batteries do heat up, inverters do heat up, and you need a cooler environment. So we've never had to use air conditioners on our sites. We just need an exhaust fan for better air circulation, but we've never needed to use an aircon. So that reduces the energy cost for us, which is essentially auxiliary energy that we could normally not sell. So we could have a more compact design, and then we could save on energy quite a bit. So that was an additional cost benefit also we got out of this solution.
All right, thank you. Of course, even when constructing powerhouses, in terms of the ventilation and in terms of keeping everything inside cool, I think that is something you can flexibly construct to the local conditions and specific to the local environment. Maybe one thing I would like to say, in favor of the powerhouses, of course, if you actually own the land as a mini-grid developer, then you are really constructing something very long-term that, will stay there in that community. And it's, again, something that maybe the community will also appreciate, right? Having a fully constructed building that even if you were to leave or abandon the mini-grid with time, that they would have something long-lasting that is in the community, even if you're leaving.
I also wanted to go back to something that Abhishek, that you were saying about air conditioning and the insulation, and I think that that's very true in Uganda and in this sort of tropical region, Rwanda, Uganda, Lake Kivu, Lake Victoria. You're in lakes, there's not as much dust, the temperatures are fairly moderate, and that is probably very applicable. And I think when we have deployments, in Kakuma refugee camp, which is super hot desert with the finest dust, and people are roasting, or up in South Sudan or in sort of harsher environments, I think you do need to consider air conditioning. And I think that is another part of, it's of course a part of the system design. And I think I just wanted to mention, containers. We also do installation in the container. We manage the thermal flow, and I think that's just an important consideration in all kinds of environments. So I just didn't want to leave that one hanging, that you need to ensure the environment is considered in the design. And then
I think Abhishek would like to respond to that first of all.
Sure, Julie. Yeah, the point is taken. It depends on the context. So if it is in a Kakuma setting, yes, we would need air conditioning. But I think the larger point is this benefit of having the insulation itself, because it is a polymer insulation. There is going to be a temperature gradient. It is going to be cooler in the room, no matter what setting, because polymer fibers or polymer based insulations are called in insulation because it reduces the amount of heat that can come into the room. Both the cases, you would require air cons in a setting like, say a Kakuma, but the running of the air conditioner will be lowered, and with lower temperatures already within the room, you don't need the operation of as much of the air conditioners. So just that efficiency aspect of it.
Oh no, we insulate our containers. I think that's the point, because we have the same kind of thing as a panel with the metal strips on the outside and the polymer. We have 40 millimeter and 50 foam. We've insulated all of the walls as well. So from that point of view, I think we're equal. I feel like we're fighting. We don't need to fight. I feel like we're both doing the same thing and it's great. Yeah, there are definitely, I have seen containers that are not insulated. And I do think that works in certain environments. But by the time you start getting into these more extreme regions, you need to have the insulation. Yeah.
Yeah, good. That sounds like we've agreed. Abhishek, do you have any experience with how the community has reacted to, you bringing the prefab solutions? How do you ensure community buy-in?
Sure, I don't think there were really applause or claps when they saw this. So we don't know that aspect of it as like what the feeling is. But in a prefab structure basis, they've seen it before. Most remote telecom towers in Congo have a prefab structure. Some of the health clinics have a prefab structure. So on our island, there are like at least 2 health clinics which have a prefab structure. So this was not new for them. So they understand what the prefab structure is. So there was not much of a reaction apart from, yes, we've seen this before. They were just curious about what would the shape be and how long it would be, because a telecom tower prefab structure itself is like just a tiny box. So I think that curiosity was there in terms of like they seeing us install, they visiting us. But apart from that, I don't think there was any appalling reaction. But to answer one thing that you particularly asked, when you said that a concrete room could be used for other purposes, I think this is something that we did have a discussion with our community, because we do share transparently in terms of what the project is like and what do we do in the land, because we buy it or we lease it for a long period. So even the owner of the land who leases it to us is definitely curious about what are the activities and what this project is going to be. And one thing that they did realize that, be it 10 years or 20 years of the project life or however long we are on that project, we leave the site as we found it, because they can then use it for agriculture, they can use it for cattle shed, they can use it for however they please, even for constructing a house. So we felt like the prefab solution was better because we leave it as we found it. And I think that's something that they also agree. So they do not really question the aspect of whether these panels will be taken out or will something be left on that land, because they want that flexibility as well.
Okay. Interesting. Yeah, that's a fair point. Obviously, with many of the mini-grids, I believe we haven't yet really seen what happens when they get decommissioned. I mean, at least for our sites, Jumeme on the islands in Lake Victoria, we're lucky enough for the grid not to have obviously approached anywhere near there. And so I think for now, the locals are happy to have the powerhouses there. And as far as we understand, they're also happy that these powerhouses will continue to be standing there. But obviously, we haven't come yet to that end of life point, really. Actually, it would be just interesting to understand also in the containerized solution, have you actually witnessed or have you seen any containers being shifted from one site to another? Has that already occurred?
Yes, it has. Actually, the Utility 2.0 container that's used was the SE for All project. That one has been relocated. And then also in refugee settlements, it's a bit tricky because some of them are not supposed to be permanent. It's not intended to be a permanent settlement. And so they have a hard time getting funding for things that are permanent. So there's a lean towards a containerized solution because you can technically pick it up and move it away. It might be there for 25 years, but it's not permanent. So there's just a little bit of impermanence can be a value add for certain projects, certain off-takers.
No, that actually makes a lot of sense that I've never thought about that before. But it is true that the likes of UNHCR and so on, they can't enter contracts that are longer than a certain period of time, sometimes even 1 year, 2 years. And then for them, containers would make a lot of sense. But even for containers, I believe that you, in any case, always have to construct a foundation, right? Or is it that you sometimes just drop the container on the floor without foundation?
It's not a full foundation like a house. You can put 4, what are they called, like cornerstone pillars. And sure, people just do drop it on the ground sometimes. Depends on the site.
But when they do drop it, it might get wonky, no?
Right. Yeah. No, you should level the site. You should have some civil contractors there. Anyways, you have to lay down a whole field of solar panels, and those have to be leveled properly. So there's a certain amount of technical expertise involved. But yeah, you don't have to dig a whole huge foundation every time.
Yes. I mean, I believe that was in fact one of the main reasons as to why we have also gone with constructing powerhouses, because as you're saying, you anyway need to do some sort of civil construction on site. Why not just construct the powerhouse? But I do agree that in terms of the cost aspect as well, it's a bit more, I would say, risky to construct powerhouses because you never know what happens. Again, in our case, we're very lucky to have a good foreman and good workers on site, but it can end up costing you more, of course, especially also there not being any power on site yet when you're constructing. That means if you're doing any welding and so on, you're going to have to get a diesel genset there, utilize that. And yeah, of course, that can be costly. But again, with the containers as well, as you mentioned, you do need to get some way of offloading them from the trucks. So that means you need to get a crane there. So again, different cost aspects to consider. Yes, Julie.
Often the truck has its own crane, just to say. And I'm wondering if we can talk about the longevity of the different, I'll call them envelope or container solutions and maintenance and things like rodents and pests that get in. My experience with some of the locally constructed structures is that they're not very bug proof, right? And rats chewing wires can shut down your system and it's a real pain. It's something that you don't think of until it's already happened, and something that I think is a benefit probably with the prefab. You can seal it up. Definitely with the containers, we can put grommets, we put steel mesh, like we can completely seal off this enclosure. We have a door that closes tightly, and ideally, I mean, I'm sure rats get in every now and then, but in my mind, I think that there's a little more resistance to rodents and pests getting in and having nests and chewing wires and things like that than with some of the locally constructed things where maybe doors and windows don't always meet at 90 degrees and seal off very well.
No, that's a good point. I mean, how do you deal with that in prefabs? Is that pretty well covered? Are they closed off well enough?
Yes, it's similar. I think we did, while we were designing it, we did take our experience from a containerized solution, and we know where to seal off and how to seal the exhaust fan space and things like that. So it is very similar in that ways in design to a containerized solution. I do agree with Julie. It is, I think, better. We've not had any pest issues on these sites compared to, say, a concrete building. And coming to the welding part of it, we actually have it as a productive use on another site where there is solar. So we welded our components there. So that is like extra use of solar energy available. So I don't think it was, we used gensets for that.
All right. Abhishek, I do have two more questions for you related to prefabs. The first one relating to a personal experience that we had with prefab structures. Under the UNOPS Sierra Leone Arab program that we supported, we have seen firsthand how there are some prefab structures that we had seen constructed where there were leakages basically causing, mold in the buildings and basically rain that has come into the building and then caused all sorts of issues inside. How do you ensure that as you're doing the prefab solution and only putting things together on site, that such issues are avoided, especially when we look at areas with heavy rain? And then also, if you could please address the point of prefab structures also needing a foundation on site. How do you ensure that as the foundation is being constructed, that this then fits together very well with the prefab solution that you're going to put on top of it?
Sure, certainly. Thank you for the questions. Interesting ones. I will address the first one, which is the problem that you had faced in one of your sites. In fact, that's the same problem we faced in our concrete room where, water leaked in through the door because of a stormy situation. We've not faced that in the prefab. Now, we'll come to why not. I did address initially that, it depends on the manufacturing quality of the joints and, how these panels fix together and where there are gaps and how the gaps can be handled. So I did a personal recce around India. That's where I'm from, to look at some of the prefab structure solutions. We did test about 3 different companies that I was in touch with. Now, India is an environment which goes through extremes. You have temperatures as much as 45 degrees to 50 degrees in cities like New Delhi, and the Indian subcontinent has something called the monsoon season, which is like, heavy rainfall for like 2 months straight, incessant rainfalls. And these structures were for such an environment. So we have visited some of the facilities where this is manufactured as well as where it is installed. And some of these places are rainy as well as it gets very hot. So these were built for that environment. So we thought, replicating it in Africa, especially East Africa, in the place that we are working in, it is definitely better environments than India. I would also go as far as saying that even a place like Kakuma or like the UN refugee camps have a lower temperature variance than India has, because places can get as hot as 50 degrees in some of the regions, and at the same time it goes as low as 5 degrees in the winter. So there is a massive temperature difference. So that's how we came across the supplier, and we had a good experience in that, because we have visited the manufacturing site where we got a training of installing the panels together, and then use water to understand, with force to understand where the water goes in, what are the different features of such panels. Moving to the second question, civil works. Now, we do not wait for the components to arrive. For civil works, there's a considerable time between we starting a procurement and the goods arriving on the ground, which is usually 1 to 2 months, depending on where these goods are coming from. That is sufficient time to do any sort of construction. Similar with the concrete building as well. If we have time for 1 to 2 months, we could start in advance. So we use that time to essentially lay the concrete foundation. So it has never hampered installation. So 1 month before the arrival of the system, we've already finished the concrete because it's predefined. We know exactly what the size is going to be, similar to when we did the container solution of the blocks that Julie mentioned about. The only challenge with the container solution is the mounting of it. It has to be perfect. That took a while. It took about a few hours to get it right, just because of the sheer size of the container and where the truck was. It was not leveled as such. But the civil work itself, we have that time. But once the components arrive, that's when the pressure builds up on how quickly we can install and then light up the site. So everything we can prepare upfront, we do it.
Can I ask, Abby, in the example you gave where you took some 6 panels from one site and expanded a storage room on the second site, and you said that you did that in 2 days, it was very innovative and reactive to the situation you had. How did you manage the foundations for the expansion on the larger site in such a short time?
No, we had a longer platform we had already designed for. So it was much larger than what it was initially planned for, but that was for all our sites because it didn't cost us a lot to have that space available for us. We also did that because terrain is not very conducive for such projects. So we had a lot of silt and soil erosion affect us in the past. So we do work with that allowance. So yes, it is true that if we were to expand further, laying a concrete foundation would take that amount of time as usual, but it is not as much as waiting for a container or building an entire room. It is much slower than that.
Okay, I have a question, Abhishek, again, about the on-site integration of the equipment. It's complicated. So again, bringing up my previous history at Mesh Power, we were doing smaller systems, and in Kigali, in town, we would build a frame and put on the batteries, the inverters, the bus bar, and pre-wire, crimp the cable, cut everything, measure, test, disassemble, take it out to the site, and then reassemble it again. Because once you're out at site, it's very hard to do all these things. And if you forget this tool, then you have to wait 1 or 2 days for someone to go back and get it and come back out again. So it was really about being very efficient on site. And so I'm curious, how do you at Equatorial manage the on-site integration equipment aspect efficiently? Do you do a pre-assemble in town, wherever the town is, and then disassemble and reassemble? And how do you account for the time, potentially calling that double work?
Thanks, Julie. That's a good question. So I did state earlier that it is convenient to have something that is pre-designed and installed, especially in the container solution. We did like that option, of course, but conventionally, mini grids have always been assembled on site. I mean, this has been happening for 15 years. So in a sense that I think is an overkill to say that, it is hard on site. Yes, I mean, there are these basic tool list that we have and we always package it to the site. So that's something that, we go through a checklist and we never forget. And then the rest of the crimping, everything is done on site because it puts less stress on us to have a solution that is predefined and which is not flexible in the case that something goes wrong or something in the design changes or we have an extra battery we require or we decided on the site if you're doing a portfolio of projects on how to change the design last minute. Usually that doesn't happen. The design is quite the same. It is decided quite early. But in case of, that flexibility, we've gone through a process where we probably do not want the inverter there. Well, I want the internet in a particular place, or I don't want to use a long communication cable because this has distortion effect. So these are some things that, we can obviously think about it on site, and that flexibility is useful in many terms. So we think our technicians have also gone through a couple of sites, so 3 sites, to know exactly what the thought process is. So we've not found that a challenge. It is convenient with the container, but I think we've overcome that with strong technicians on the ground and having done this very frequently.
Compared to the construction of a powerhouse, again, where you get most materials either already on site or close to site, I believe that both container, but then perhaps also the prefab solution do require a bit more procurement and logistics in terms of getting things to site. Julie, could you speak a bit about where containers are actually put together and how they get to site from wherever they are built in the first place?
Sure. At SustainSolar, our manufacturing facility started in Cape Town. There's a great supply chain in Cape Town for all kinds of solar equipment. It's a big economy down there. There's a lot of equipment that moves. And so that's where everything comes in and is integrated into the container. And then we usually, depending on the country, can take it via land, if it's just going to Zambia or Namibia, or by ocean to a port and then inland to wherever it needs to go. And that takes a long time to get on a boat, and it can take 4, 6, 8 weeks. And during that time, the developer is usually installing the solar panels, leveling the site, doing all of the civil works. There's also, don't forget, distribution networks that have to be installed. So you can do all of that kind of stuff simultaneously. And then when the system arrives, if the poles are up, the household connections are in, the panels are ready to go, you can just plug your container in and you're ready to rock. So that it doesn't have to be container first and then these other things. We have also partnered with a container manufacturing company in Kenya to service the East African market more quickly. So by the time the long lead time components have arrived, the batteries, the inverters, etc., if they're not locally available, we'll bring them in. But then once the container is integrated and ready to ship, we can ship it within the East African, within the East African region very quickly. This company that we've partnered with, they produce 200 containers a month for all kinds of different purposes. So volume is not a problem at all.
And have your clients encountered any issues around importation or getting the container into the country, or is this basically just the usual issues?
Oh, every country is different. Luckily, we've shipped to 17 different countries now and have dealt with all of the wonderful customs and clearance shenanigans in all kinds of places. We have a great team that's used to it. And we actually prefer to offer our logistics solution and team to do it for the developer because it is so complicated. And if you get the paperwork wrong and you start paying taxes on things because you put the wrong HS code, it can really cause delays and unexpected costs. So that's another area where we've shipped 100 systems to 17 countries over the last 6 years. We've built up a lot of expertise, and we like to offer that as part of the service to the developer to take that additional headache off their list.
All right, sounds great. And the prefab solutions, Abhishek, where do you manufacture them? Is it usually in the same country and the city?
Yes. I mean, until now, we've done about 6 sites with a prefab. It has always been the same supplier because it has come with like a good manufacturing quality. We've not had much issues, so we continue doing that. So in terms of procurement, we begin procurement on one day, like in terms of down payments to all suppliers. And then from then, the amount of time for manufacture is defined by the components which are going to take the longest. So prefab doesn't fall under that component. It is usually quicker. Sometimes poles do because of the sheer number of distribution poles you may need for a site. Sometimes the power electronics itself, like depending on, how customized you want for it and what is the availability of, say, batteries or inverters. So prefab has been lesser time than, these other components. In terms of importing, I would like to obviously address that. I think it depends on the country. Importing or doing anything in Congo is far difficult than any other probably country in Africa. But it was, for us, we had to recognize how we obviously pitch this to the custom agents before the solution or the components reach. So we had to obviously draw parallels to telecom network sites or prefab site that, exists on the nearest port, and we do have maintained that relationship with the customs so that after the first time they exactly know what we are importing with pictures, so that the process is a little smoother, but it is never smooth in DRC irrespective. So we are aware of that. We do consider that as a part of contingency within our project in terms of timelines.
All right. So obviously we have the benefit of being here with a live audience at the Energy Access Investment Forum. And we do have one audience member coming up to the mic to ask his question. So please go ahead.
Thank you. I'm Gabriel Mayo, a solar engineer based in Kenya and Uganda. And I have a question to Julie. Whereas the idea of doing complete pre-integration setup of the containers in your workshop and shipping to the site sounds great and brings about high control to quality, installation, and testing. How do you ensure that the local community of the site where the containers will be used are engaged, since this takes away the job creation which local builders, for example, masons and local expertise, often directly benefit from? I also have a question for Abhishek. Listening to the whole concept of prefab and the drawback around the interlocking joints, are they affected by the adverse weather condition? And how have you mitigated this risk? In addition to that, the concern around exposure to risk of vandalism. How have you been able to handle that?
Great question. Thank you. I think community involvement and engagement is absolutely critical. Any mini-grid developer will tell you that's the main, probably hardest part of their job. And yes, you're right. Bringing in a pre-configured, pre-tested, highly designed and highly specified, very technical solar power generation system does feel like it's taking jobs away from the community. My opinion on that is that it's a one-time lift for that community. It's one thing that happens one time. You build that system, and the ongoing work, that's where the job creation is. Let me say two things at once. So the ongoing job creation and community integration, now that they have electricity, now that's when the developer can get involved in sensitization to productive use and teaching people how to use the energy, growing the economic development, whether it's agri-processing or you're welding or, there's a million applications for energy with productive use in the community. And I think that's where the long-term job creation and economic growth is really important. Whether you're building your powerhouse, whether you're building a prefab solution, you're going to bring in some engineer and electrician from the city who's highly qualified, who's gone to university to come and do this installation anyways. And then that person's going to go on to the next site and the next site and the next site. So it's not a skill set that needs to stay in that community. The developers, I think, also will train some local technicians to maintain the system, but that's quite different from engineering and installing it in the first time. And that's just about the power electronics. I'm just talking about what's inside the container. There are still, when you're putting together the site and installing the site, we've mentioned civil works. You still have to install the solar panels. There's digging, there's trenches, there's laying cables, there's erecting poles, there's pulling lines. There is a lot of work involved that can use readily available labor and people from the community without requiring this one very particular skill set one time. So I think it's not a perfect answer, obviously, but I think that's the trade-off. really.
All right. Thank you, Julie. So over to Abhishek.
Sure. Thank you, Gabriel. That was a couple of tough questions that I need to think off my feet. I will answer the second question first, the aspect of vandalism. That is a genuine concern. I would think that, compared to a concrete room and a container solution, I would believe that a prefab would be probably easier to vandalize. But I would go back to the point that Julie made in a different context, however. But if you have solar panels, I would first vandalize that and I would not go to the power room. So I'm not saying that, vandalism is justified. There are solar panels which are in the open and it is fenced. So it is definitely easier to vandalize a prefab compared to the other solutions. But this also comes to the community engagement aspect of it. Our community engagement always is obviously built on the notion that this is a community project. So we've never had a vandalism issue. We obviously work with the security force locally hand in hand. So we've never faced that situation before, but if we do face it, we would be more concerned about the panels themselves. Now coming to the storm situations, yes, we are in that part of the world where storms are frequent, and it has definitely hampered quite a lot for operations, especially on the distribution network with trees following on the cables and the poles, etc. And we have had massive issues with lightning strikes and frequent storms. So in that sense, yes, that remains a risk. So we did face that in a second installation of the prefab sheet when we had only made the walls. We hadn't made the roof yet because we were waiting for the next day to do it. In that sense, it was not completely installed, but there was a storm that night and the panels fell off. That storm, to be fair, was one of those storms where you don't get too often that uprooted the roofs of a lot of our customers, and it was a terrible situation, sadly. So for us, that was not a big loss as such, but we did face that consequence of what happens if there is another storm or probably stronger than that could probably destroy the wall, because it is on the top part, at least it's like a hinge on the interlocking joints, which are strong enough, but a strong wind force could do it. So we did add U-bolts on the foundation to the concrete itself. We did obviously pivot there to get that strength on the ground. But yes, if it is a direct longitudinal wind, which is hitting perpendicular to one of the walls, who knows, with high force in the Buffer scale of the wind velocity, this could happen to a prefab more than a container or a concrete solution. I hope that answers your question.
Okay, can PV panels be installed on prefab solution?
That's a good question. We haven't tried that. I think it has the strength to install it, but we do ground mounted PV, so we don't have PVs on our power rooms ever. But that's a good question. I think we will try that on one of our sites, and we'll let you know if there is a following debate on containerized versus prefab.
Great. All right. Before there's a following debate, I think we can wrap up today's debate. And I would like to give both of the guests a final opportunity to give their final pitch and to, tell us why their solution is great or not, or what they have learned today. So yeah, Julie, I think you're up first.
Sure, thanks. It's been an interesting conversation. I like the idea of prefab in the right situation, and I can see that there are certainly situations where the container won't work. And I think that if you're looking for scale, you're looking for speed, you're looking for predictability, and you're looking for performance. For example, if you're a developer and you've won a tender to deploy 30 sites within 1 year in an area that's by definition hard to reach and doesn't have power, then I think ordering customized, pre-integrated, containerized systems that are built under controlled conditions and tested and ready to deploy will save you time, it will reduce surprises, and it will allow you, the developer, to really focus on what you're actually trying to do, which is electrify the community and work with the people in the community and do your revenue collection and actually operate the mini grid. So I think that's our the final pitch.
All right. Thank you, Julie. And Over to you, Abhishek.
Yes, similar. I think we would stick with the prefab solution now because I think that has been working great. I mean, especially the flexibility, the scalability aspect for it. I think it is better than most of the solutions we have. And that is the benefit that we've come across on our sites. And we like it whether we want to partition a space into smaller rooms or increase the space into larger rooms. It is just a matter of adding or removing panels, right? So it is a modular design, easy to install and literally easy to get to hard to reach areas, whether it's like, physically hard to reach or like, in terms of like bad terrains or like, up a mountain or like, valley where, you can't probably take a truck. We can do that because we do not need the use of heavy trucks or solutions that require other aid to like, pick up and drop things. So that is definitely another advantage of it. Overall, the community has accepted it well because it's seen such a solution before. And there is community involvement in all aspects of our project, be it construction, laying the panels, etc. But this also comes with its own need for labor to put the system together, a sense of empowerment in doing that, using welding, using a welder, which normally would not be used in constructing a project. So there is an aspect of community engagement in this. And yes, it has worked well. One more thing, we can rebrand very well with a prefab. You just have to shift the panels if you want to change the name. For instance, saying ARE to REA, like, it's simple. Just turn one panel into the other and you have a new brand now. Anyways, jokes apart, I think prefab is an easy solution and we would like continue to go with it until the circumstances change.
Great. Fantastic. So there you have it, folks. Some compelling visions for the future of mini-grids in sub-Saharan Africa. And whether you're team container, team prefab or team powerhouse, I think it's clear that there's not necessarily a one-size-fits-all solution. It all depends on the local context, available resources, and the goals of your mini-grid projects. Thank you so much for joining us today at the Energy Access Investment Forum 2025 in Kampala. And thank you so much to Julie and Abhishek for joining today's episode. And also, again, once more, thank you to all our listeners for tuning in to the Mini-Grid Business. And we'll catch you next time where we'll continue to spark the conversation on renewable energy and sustainable development. Thank you so much.
Thank you.
Thank you.
This episode of the Mini-Grid Business has been brought to you by Enensys, your one-stop shop for sustainable mini-grids. For more information on how to make mini-grids work, visit our website, enensys.com, or contact us through the links in the show notes. The Mini-Grid Business, powered by Enensys.